In this video, we are going to look at the rules for exponents and then some examples of those rules. So when we have a multiplication problem, our rule is that we add the exponents. So in this example, x squared is times x to the fifth, and so that would give me x to the seventh power by just adding the 2 and the 5. How does that work? Well, x squared is x multiplied by itself, so there are 2. X to the fifth is x multiplied by itself 5 times, so that gives me 5. And if I count them all up, there's a total of 7. And so that's why I can use addition rather than having to write them all out. The second rule is that when it's division, I should subtract the exponents. So it's always subtracting top minus bottom. So in here, 5 minus 2 gives me x to the third. How does that work? Well, x to the fifth on the top is 5 x's. X squared in the denominator is 2 x's. And then x divided by x cancels out to be a 1. So I'm able to cancel 2. I have 3 that remain, and they are on the top. And so that is how I get x to the third. Our third rule is when exponents are both outside and inside the parentheses, we have to multiply them. So I will take 5 times 4 and have x to the 20th. I'm not going to write out all of these, but I think that you get the idea. So I would have x to the 4th 5 different times, because the exponent on the outside is indicating how many times that I would have this. So once I write out those, I can then see that I could add these up using the first rule. So 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20. Or my shortcut is to multiply. My fourth rule is that a negative exponent moves that item to the opposite half of the fraction and it becomes positive. So when I look at this particular problem, I don't see a fraction, but I know that any number or variable can be a fraction by writing it over 1. So when I write it over 1, I see the numerator and denominator of this, and so I will keep the a squared in the numerator, and I will move the b to the fifth to the denominator, and by moving it, it becomes positive. Now you may be thinking, where did this come from? Well, if I look at a similar problem, if I had x squared divided by x to the fifth, we did this in reverse earlier and got x cubed, but with the x to the fifth on the denominator, the problem would work out slightly differently. So if I write out all my x's, I can see that the first 2 x's cancel from top to bottom. I can see that there are 3 left in the denominator, and so I would think my answer would be 1 over x to the third, because there are 3 left in the denominator. Well, that's the correct answer, but how would I get there with a shortcut rather than writing it out? I know that I should subtract. I know that I should take the top minus the bottom, which would give me x to the negative 3. That negative 3 is indicating that those 3 x's should be in the opposite part of the fraction, and so I would move them to the denominator of the fraction, and you can see that I now have matching answers. So this shortcut, when we have the negative, it needs to move to the opposite portion of the fraction. The final rule is that anything to the power of 0 is 1, and so the answer here is 1. And again, you might be thinking, well, why does that work? Well, if we look at our division rule, x squared divided by x squared, we know that x squared represents 2 x's on both the top and the bottom. We see that the x's simplify or cancel each other out. But we know that when we simplify the x divided by x, we get an answer of 1. If I look at this by the rules of division, it says we should subtract the exponents. So 2 minus 2 is 0. So that would be that I would get x to the 0 for the same problem. Well, no matter which way I do the problem, I have to get the same answer. And so we have defined x to the 0, or any variable to the 0, or any number to the 0 power of 1. Now we're going to take a look at some sample problems. So I'm going to pull in a Word document, and we're going to attempt to write on this Word document. So these are just sample problems applying the rules. The first one, the rule says when it's multiplied, we should add. And so from that, I get x to the 9th. Second rule, when it's division, we should subtract. So I get m squared. Those are like directly out of the notes. The third one is a little bit different, and I put it in here as an example on purpose to talk about this. We know that we should multiply, and it applies to both parts. So the 3 has an unwritten exponent of 1. And so when I multiply, I get 3 to the 3rd power. And then I get a to the 6th power. So I go to my calculator, and 3 to the 3rd is 27. A to the 6th is my answer. We'll look at some others like that again so that you see that rule in action. The fourth example, again, this one I put in here on purpose because of the nuances of it. The 0 exponent only applies to the a. So from our rule, anything to the 0 power is 1. So this would simplify to be negative 3 times 1. But the 0 exponent, because it was not in parentheses, did not apply to the negative 3, so I multiply this out for an answer of negative 3. Next example, this is like the third example. This exponent of negative 2 applies to every single part, and it gets multiplied not by the number, but by the exponent on each piece. So the 3 has an exponent that we don't write of 1. So when I multiply, I get 3 to the negative 2. M, 2 negatives make it positive 4. N to the negative 8. Now I have to apply a second rule. And that second rule is that those that have the negative need to move to the opposite part of the fraction. So m to the 4th had a positive exponent and will stay on the top of this fraction. 3 will move to the denominator, get an exponent of 2. N moves to the denominator, exponent of 8. If I do one more step here, I would have m to the 4th, and then 3 squared is 9, and I have n to the 8th as my answer. For our next example, the only issue that I see is the negative, but I also see that the x values are here twice. So the order that you do these things in doesn't matter, but we will have two steps. We will need to combine the x's, and so I'm going to do that first, and then we will need to make sure we have positive exponents. I'm going to do that second. So when I combine the x's, I have 2x to the negative 30. Now, this is where I have to be really careful. The negative 30 only applies to the x, not to the 2. So the 2 stays on the top of my fraction, and the x to the positive 30 goes to the bottom. So in a very similar way that the a to the 0, that 0 only applied to the a, this negative 30 only applies to the x, and only the x moves to the denominator. Our seventh example, 8 and 8, if I subtract them, I get y to the 0. And we know y to the 0 is just 1. Our next example, again, this is that 0 exponent. This time, because of the grouping of the parentheses, the whole thing is to the 0 power, therefore equal to 1. Our next one, without parentheses, only the y is to the 0 power. So I have negative 5 times 1, because anything to the 0 power is 1, and then I multiply and have negative 5 as my answer.